So today we will see the supervised learning model, and first model we will see that is a linear regression. As a basic and fundamental part of the linear regression as we know. But before understanding the linear regression, what is a linear regression? First, I will tell you what is mean by the regression. In the lecture 3, third lecture, the previous lecture, I mean to say that over here, we have discussed what is mean by the types of the machine learning or flavor of the machine learning. We have seen the two type of the machine learning. One is the supervised and unsupervised learning, and last slide which contain the reinforcement learning. So in the unsupervised learning and supervised learning, we have also seen the its sub flavors, and supervised learning we have seen the regression and classification. If talking about the unsupervised learning, so we have discussed the clustering and association. So starting from the supervised learning as an introductory part, what is mean by the supervised learning? What is a supervised learning? We have already discussed. So from the supervised learning, we are trying to pick a simple concept that is a regression. So under the regression concept, we have a linear regression. So today we will see the regression only. That is more important, but regression is not a simple topic. It is a very huge topic, a vast topic, which contain the various sub flavors. So we will see the only first flavor, that is a linear regression. Okay, so from this point, I'm going to start the what is a regression. So now this slide which contains the what is a regression. As a fundamental, what is the regression as we know. So but for a revised purpose or for a quick idea, I can share my thought over here. The purpose of the regression to provide an efficient model, and that is used to predict the dependent attributes. So how we can say this is the prediction will be done. So from the bunch of the from the pool of the independent variables, we can easily identify. Let us take an example for betterment. If I need to find the student age, so student age or any person age is depend on the height, but reverse process I can understand easily. So student age is not depend on the height. Height is an attribute that can be depend on the age. So I can say speak over here in simple way that any person's height is depend on the age. So when you were the 2 years or 3 years old, then your height was 1 feet or maximum 1.5 feet or 2 feet maximum. But when now you grow up, now you have becomes 18 years old or 19 years old. Now you have your height of 5 feet, 5.5 inch, and so 5 feet 5 inch, and so many things we can say. Maybe the 6 feet or maybe more than 6 feet, depend on the your genes. So we can say the height set an attribute, height set a parameter which can be depend on the age. So age is what age is would be our independent variable, and what is the height? Height is our dependent variable. That is the point. So height is depend on the age. So this is what this is independent variable, dependent variable. So regression problem is when the output variable is either real or continuous value. And why we are using regression? Because the output variable could be found the real or continuous value. An example: salary, height, weight, area, and other parts as well. So we can also define the regression as a statistical means. It means definitely with the help of the statistical model we can use. So as we know, regression in which we have to use a linear regression. So with help of the linear way or the straight line equations, we can depict our model. So that's why we can say the regression is a representation of the statistical model, and in which we have to use the statistical data. Just like example, the housing investing. So if I'm purchasing a house, I will tell an example in the next slide. I will tell you in detail way, but I'm just explaining simple idea. So investing. So today I have the 10,000 rupees. I'm investing 10,000 rupees to the some investment purpose to the bank or some other places. So after the 5 years, after the 10 years, or maybe 6 years, I can say the my amount 10,000 I have invested, that is increasing day to day or year by year by year. It is increasing. So what is happening over here? On the basis of the years, my amount was increasing. So the investment amount will be increased by the year. So year will be the independent variable, and our amount is based on the year. So your investment amount would be in form of the dependent variable. So that is the point we have to understand properly. So this is just idea about the regression. So we have discussed right now. So this is the point. This is an example I need to discuss over here. What is this example is telling to us? Housing. So in this case, you can easily say, suppose I need to purchase a house. So in the 2020-21, I'm purchasing, so it costs around the 10 lakh something. Suppose that. But in the coming years, definitely my house cost will be the increase, definitely. So if I'm taking a simple example, 2010, I have purchased a house. Suppose that. So the cost was a 20 lakh. And 2015, I asked to someone, a broker, so what would be the cost of my purchased house? He said 25 lakh. And 2018, I was asked one more question to same person. Then he said 29 lakhs. Now your house becomes the 29 lakhs rather than the 20 lakhs. So as year changes or years updated based on the years, I can expect between 2000 to 2025 my house cost be around 30 lakhs. This is the point I am expecting. So if I'm selling my house after the 10 years or 20 15 years, so suppose I'm selling the house 2032. So what would be the cost of the my house? So definitely that is the production. Based on the my these inputs, these data, and this is known as the data set. So that is the example I can take over here. Based on the these data set, based on the these inputs, I can say this is the prediction I have to do. So 2032 prediction will be our assumed data, and that is known as not assumed data. This is the predictive data we can get, and how we can get definitely with help of the regression approaches. So on the left side, you can easily see, on the right side, you can easily see the price and years are the two important parts I have mentioned over here. So I can write once more over here for a betterment. You can easily see this years become the independent variable. This year becomes the independent variable, and price will becomes the dependent variable. So how I can say the price becomes the independent variable? Because price will be the depend on the year. So in this year, the price of a product was suppose 30 rupees, and next year the price becomes of such product is 20 rupees or 40 rupees. So after the 5 to 6 year, I'm observing the price of the such product was increasing. So this price is depend on the year. So definitely I can take real example in this before the pandemic situation or the COVID-19, the food oil, you can see the any soybean oil or any mustard oil, the approximate rate was the 90 or 95 rupees only. But after the this COVID-19 or this lockdown situation, we can observe now you just need to food oil from the market, that you can say the cost is around 180, 195 or 200 or 210, depend on the products or depend on the companies. It is just double. So what is happening year to year? The cost of the oil was increasing daily. For example, like you can take the petrol. In 2010, the petrol cost was the 65 rupees something. With 2010, in 2020, now you can observe the petrol cost was petrol price was 90 rupees. Now 2021 we are living, so as we can say the cost of the petrol is 110 rupees for the per liter. So what is happening year to year? The things are changed, and that is what that is the example which can be represented by the our regression approaches. Okay, so far this concept is clear. What is regression and what is the dependent variable? What is the independent variable? Now it is clear to all right now.
Yes, sir.
Okay, any doubt so far? Just tell me. Any doubt so far?
No, sir.
Okay. So after this point, we have a first flavor of the regression, that is a simple linear regression. Do not read the unnecessary theory. I have just given over your notes purpose only. Just read the important points which are required to understand only. So just read the highlighted point. In the simple linear regression, we predict the outcomes of a dependent variable based on the independent variables, and the relationship between the variable is linear. That is the important point. So independent variable we have, okay, independent variable we have, and dependent variable we have. Independent. Actually, let me write correctly. So this is independent variable, and this can be represented by the x-axis. This can be represented by the y-axis. So if something is plotted on the our graph, so this is the data points. All the red dotted are represent the data points which are plotting on the our graph. By using the y equal to mx plus line, if I am plotting a line, this line is known as the linear regression line, and this is known as the regression line. This is also known as the regression line. This is known as the regression line. This is known as the regression line. So dependent variable we have, independent variable we have. So based on the independent variable, our dependent variables will be predicted. So we are plotting all the data. After plotting all the data, linear regression and regression line is showing this is the straight line. Why this is a straight line? Because based on the y equal to mx plus c, and y equal to mx plus c is the equations of the our straight line. So the data which are plot on the line, those are known as the our best fit data. I will tell you step by step. So you can observe that this is data. This data is plotted on the line. So this is what this is. Let me draw the different color. So this will be perfectly visible. This is the point. So this is just plotted on the line. So this is known as the best fit data. Best fit data point. But some other points, some other dotted or some other data are not plotted on the line. So it means the regression line determining that is the our predicted points, but actual data are plotted on the some other locations. So the location of the actual data, plotted data, and the expected data we are expecting, these are the gaps. These gaps are determined by the error. So let us understand all these things with the help of some other example, some other diagram. So everything will be clear by the some example. But in this graph, what we are getting, the independent variables are used to predict the some values, and those values will be recognized by the dependent variables. So we can say dependent variables are dependent on the independent variable. This is a statement I was discussing. So simple linear regression is a regression technique in which the independent variable has a linear relationship with the independent variable. So the straight line in the diagram is the best fit line. So that's why I spoke the data, plotted data which are coming on the line or which are lie on the lines, that those are known as the best fitted data. So that's what we have done. So what is our objective? What is our goal? Our main goal to simple linear regression is to consider the given data point and plot the best fit line to fit the model in the best way possible. So that we can say that our accuracy of the model will be better by the other way. So that is a point we can easily say. So from this point, we have to identify our objective should be clear. The accuracy, the error in our data point should be minimum. That is a point you people are required to understand. Okay. So far the fundamental part is clear. And before moving to the next part, I have so many slides which contains all the details. But let me know right now. So far, I am discussing what is dependent variable, what is independent variable, and what is the simple linear regression. Is it clear to all right now? And what is the best fit line?
Yes, sir.
Okay.
Yes, sir.
Okay, good. So now question is not ended over here. If you're talking about the best fit line, so how to decide what is the line which is the best fit? So line of the best fit is drawn by the represented the relationship between the two or more variables. So to be more specific, the best fit line is drawn across a scatter plot. So scatter plot means we will use a graph which is used to plot all the data points on our graph, and such is graph is known as a scatter graph. So all the data points we will use. But the line which is represented by the y equal to mx plus c, so the line which is known as a regression line, or that is also represented by the regression analysis. But a student can ask the question, so what is regression analysis? So regression analysis makes use of the mathematical model or mathematical methods such as least square is to obtain to definite relationship between the predictor variables. So these predictive variables means the independent variable, and target variable means dependent variable. So when you look these terms, a target variable, independent variable, so all are having the same sense. And we're talking about the predictor variable, independent variable. So all these terms are recognized by the same meaning. Okay, so do not have any confusion. So relationship between the predictor variables and target variables we have to identify. But you can observe here, it is very simple concept. If the data points which are not on the line, if data points which are not on the line and which are plotted on the far from the line, so there is a gap between the line data points and the actual data points. So the gap we are getting, we can measure such gap by the error or differences. So the differences between the actual data point and our predicted data points, that is could be on the line. So what we have a gap, we have an error, we have the differences, and these differences could be positive, negative. But my dear students, please listen, error cannot be negative. As a mathematical rules, an error cannot be negative. So what is the way by which we can troubleshoot such problem? So it is a better idea, we can make the square of our error value. So error can be transformed into the positive and pulled by the double error, and that is known as the square error. Okay, this is a fundamental step we have to keep in mind, and we will try to emulate with the practical as well. So the least square method is a simple method by which we can try to find the most effective way by which we can draw the best fit line to determine all the things, and it is based on the idea that is the square of the errors obtained must be minimized and the most possible extent, and hence the name we have a least square method. So that is the point you people require to understand what is least square method. So this is the definition, this is the idea about the least square method. So I'm highlighting this point over here properly. So in the next class we will see theory part, we will see also the practical part as well. So the picture, the idea will be clear to all the people in simple way. What is least square method and what is this way. This is the point we have to keep in mind. So regression analysis means the analysis by which we have to minimize the error. So that is the point we have to keep in mind. Okay, this part is clear to all right now in this slide.
So please explain it again.
Okay, regression analysis is an analysis that is a mathematical method in which we have to analyze our result or outcomes to minimize the error, because in this case, in our regression point, we can have the many error. Now, how you can say what is the error? Error can be easily identified by the plotted actual data point and the data point which could be on the line, because line is which is our best fit line, and which is depicted by our y equal to mx plus c equations. Okay, so with this point we are drawing a line that is y equal to mx plus c. So after plotting this line, if we try to plot the actual data point, so the data point that should be on the line, but which are not on the line, which are plotted on some other places. So the gap which is coming from the actual data point and the line data point, predicted line data point, that is the differences we can say that could be the error. But error cannot be a negative. Error would be always a positive. So error, while calculating or determining the differences, the error can be positive or it can be negative. So to overcome such problem, what we have to do, we have to make the square of our error, and with the help of the least square method, we will try to minimize our error, and that is our objective of the regression analysis. And when we have tried the basic fundamental concept to find to minimize the error, and we have a least square method. So that's why I have highlighted in the last and the bottom side. Now clear? Just tell me right now.
Yes, sir.
Okay. Okay, no problem. The with the help of the diagram, everything will be clear. Don't worry. Okay. So now move to this point. Right. This was the point I was discussing. Do not go through the theory point. Just look at the diagram. The predicted line, the predicted prices. See, there is some based on some problem. So based on the time, our price will be hiking. Just like example, our petrol price you can take, the house price you can take it. So in the year 2010 to 2021, the price of any product or price of the petrol was high. So you can observe what the gray color or the brown color data points which are representing the actual data points. And this red color line or dark brown color line will representing the this price could be the predicted price. So after plotting all these data point, actual data point and predicted price, so you can observe that this is the some data point. So I can mark this is a data point. Just look at the corner side. This data point is just on the line. So we can say there is no gap between the actual data point and the predicted data point. So it means there is no error. But when looking, we're talking about this data point which is representing over here. So I'm marking here. So see, here we have the gap. That's why I've written the differences. This is the differences we are getting. So I'm highlighting this word differences, and this difference is also known as the error. Look at this data point. This data point I can mark by the another. See, the data point should be, yes, this is our actual data point. This is our actual data point, but this data point should be on this point based on the predicted points. So this is what, this is the our error. This should be on the line that is predicted, but this is our actual data point, and the gap we are getting from this predicted line location to the actual data point. So this is our gap. This gap is known as the error. This is the gap or the differences we have to identify. This is known as our error, and this could be positive or negative, depend on the our calculated part. So but this cannot, the error cannot be negative. Error would be always in the positive. So what you can do, you can use the scare purpose, if scare. So definitely the error would be in form of the positive. So this was the point. Now this diagram is clear to right now.
Yes, sir.
Yes, sir.
Okay, so that is the point. See, this data point is also on the line. Just look at my point. I'm just marking. This data point is on the line. So there is no gap between the actual data point and predicted data point. So here the error would be automatically 0. That is the point. Okay. See, this is the diagram which contains all the information properly. See, this dotted line is known as our predicted line, and this will be generated by the our y equal to mx plus c equations and regression line. So what is the y? This is the y, and we can get the y value based on our input x. So this is our x. If this is our x, so I'm putting something, I'm putting here all the data, and how I can calculate the m. What is the m? M is the slope, and c is the intersection point. So based on the intersection point, you can put the detail of the m and c, and respectively x. You can calculate the respective value of the y. That is the point we are getting the our straight line equation. So this would be the estimated value, or this would be the estimated value, but this is actual value. This is our actual value. This should be our predicted value, or this should be our estimated value. Okay, this would be our known as the predicted values. Predicted values. So the gap between this data predicted values and actual values, we have an error. This is known as the error. Okay, same thing. You can go from the go for the upside. The actual value we have, and this could be on this point. So the gap we are getting, that is known as our error. So what is our objective? Our objective to minimize the error. Our objective should be clear. Our objective would be to minimize the error. If we are having the many errors or huge error in our models, it means our model of the accuracy or accuracy of the model, we can't say we are getting the better model. That is the point. Now, from this diagram, everything is clear to all, or anything you need to ask, so please you can ask me right now. Just tell me right now, anything you need to ask.
No, sir.
Same thing, this is our actual values, actual data point, but it should be on this point. So the gap, we can easily say, here in this, we are getting the gap, this gap, this gap, this is a gap. But this is the data point which is on the line. So in this data point, we can't say we are having an error. So for this data point, we don't have any error. So the error would be 0 automatically. But here we have the gap. Okay, here we have a small gap as well. This is the point. So this is our point from which we need to identify all the details. Okay. So far, anything is clear to all right now? So far, everything is clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So the question we should have in our mind, sir, if we're talking about the y equal to mx plus c, so how to calculate the line of the best fit? Undoubtedly, as the basic mathematics of the 10th or 11th or 12th standard, I can speak over here. Y equal to mx plus c is our equation, because we are talking about the linear regression. So in the linear regression, with the help of the line straight line equation, we can evaluate our best fit line. So undoubtedly, we have this point. So y will be the dependent variable, or x will be our independent variable, while m and xc will be the slope of the line and y intersection point. So with this basic fundamental point, you can easily calculate all the things. So some student ask me a question, sir, how to calculate the slope? So this is simple way. M equal to n summation of the xy minus summation x multiplied by the summation of the y, and the divide by the n x square, summation of the x square minus a summation of x whole square of the summation of the x. So with this formula, we can calculate our slope of the data points, all the data points. That is a point we have to understand. So this is a basic fundamental point. And how to calculate the intersection point? C equal to y minus mx plus c. After calculating the m and y and x respectively, we can easily calculate the intersection point. So this would be our main equations, y equal to mx plus c, y which we can get all the data properly. So no need to discuss more over here, because this is all these concept mathematical things will be involved in our predefined functions of the machine learning model. So we are not required to calculate implicitly. Explicitly, we are not required to calculate anything. Everything will be in the implicitly form. So from this point, we have to understand what would be the cost function. As I told you many times, what would the cost function? So as you know, the y equal to mx plus c is our line by which line straight line equation that will be the used to evaluate the upper model, the integration model. So cost function definitely would be the y equal to b0 plus b1 x plus c. I can write this equation in simple way. How I can write? I can write this equation like y equal to mx plus c. So intersection point is also required, slope is also required, and x also required, and y also required. But this e is also added over here if there is some error in the such data points, actual data points are difference, actual data points and predicted data points. So the error will be the such gap or such differences. But if we don't have any error, it means that data points are the predicted data points are on the same line, or best suited on the line, then we can say the error would be automatically 0. So this would be our cost function which define the y equal to mx plus c. plus E. So this is our cost function we have to keep in mind, because everything we are managing we are managing with the help of the straight line equation. So that would be our cost function y equal to mx plus c plus E. Okay, so this is clear to all right now, the linear regression terminology. Anything you need to ask from this point? Yes, tell me anything.
So
Because
what is cost functions actually?
cost function, the cost function is a function by which our model will be evaluated. That is nothing else especially. What is the cost function? Cost function means what is the cost function by which we can evaluate our model and by which we can determine the cost of our model. So that is only our straight line equation by which we have been applied this equation inside the linear regression. So we are getting our linear regression model. So that's why it is known as the cost function. Now clear?
Yes, sir.
Okay. Just read this highlighted point over here, the error. So as I told you before, while starting the class and while discussing the linear regression model, the regression is saying to us our objective or our main goal in the linear regression or any kind of regression to minimize the error. So how we can evaluate the error? How can we calculate the error? So the formula is very simple. What is the formula? Error is minimized in this problem between the actual values and predicted values. So the differences we have to determine. So how to find the differences? The predicted values minus actual values. You can take the reverse part, doesn't mean, because finally we are doing the squaring. So we square the error difference between the sum of the error overall all data points. So first what we are doing, we are getting the squaring and then we are getting the squaring. So summation function, summation operator I am using, summation symbol I am using here to get the sum of all the values in form of getting the differences and square differences we can say. So square the error differences we are doing and sum of the error we are getting of all the data points, and finally what we are doing, we are getting the division by the n. So it means we are getting the mean square error. So first what we are getting the error. So error can be easily quoted by, we are receiving the error, we are getting the error with the help of the differences between the actual values and predictive values. And after we are doing what we are doing, we are doing the square. I'm doing the square. So why? Because error cannot be negative. So after getting all these things, I will get all the square values of that part, and I'm doing the summation. So what after doing the summation, so I'm getting the square error. After getting the square error, if I need to divide this square error by with the help of the average value of mean. So what I'm getting the term which is known as the mean square error. So I'm getting the mean square error is what? Mean square error is our basic parameter of formula or factor by which we can determine what would be the cost of our model. So this is our first measurement criteria to measure our model, that is the mean square error. Unlike mean square error, you can use the absolute. If you do not want to make you represent your error by the square, you can make the absolute. So instead of the squaring, if I want to put the absolute value, then I can put, because negative value becomes the positive automatically by doing the absolute function or absolute way. So at a time, such function which is known as the absolute error we are getting, and after that we are getting its mean. So that's why we have the mean absolute error, and that is also another parameter we will see. That is definitely we can see. And mean square error we can minimize by the getting the square root of our such values. So the value we are getting the mean square error, we can find the square root, so automatically we can get the minimum values. So our objective should be clear. Our objective is to minimize the error inside the linear regression model or any kind of the regression model. So the first parameter you have to keep in mind, the first parameter of our linear regression model or any regression model by which we can evaluate, that is the mean square error. Second one is a mean absolute error, and third one is a root mean square error. With the help of the practical, everything I will show you. Okay. Now, is it clear to all right now? The fundamental concept is clear to all right now?
Yes, sir.
So what is the advantage and disadvantages? Advantages we have and disadvantages we have. Advantages. Linear regression perform exceptionally well for the linear separable data. Of course, I agree with this point. But disadvantage, we can say the assumption of the linearity between the dependent and independent variable we have to. And due to this disadvantages, we can get some noisy data and overfitting may have. So this could be the second disadvantage. But what is the second advantage? It is easy to implement, interpret, and efficient to train. Of course, I am 100% agree. And it is often quite prone to noise and overfitting, of course, because there is no guarantee we can get all the data points on the line. There may be some chance we can have the many gaps between all the data points which across the line. So definitely what we can get the huge volume of the error. So our model will be overfitting. So overfitting means our model is not fit towards our line. It is just far from or it is just not fit the model. That's why we have this problem. So underfitting, overfitting, and average fitting, we have that part we will see in detailed manner while discussing some other topic. So overfitting, underfitting, you will see while discussing into the neural network. So overfitting, underfitting, and average fitting. So our model should be average fitting. Our model should not be underfitting. That is the point you have to keep in mind. And it handles the overfitting. So overfitting problem can be resolved by applying some additional methods. Those are known as the dimension reduction or regularization and cross validation. So with help of these methods, you can reduce the overfitting, but you can't remove. You can reduce or you can handle the overfitting. So that is the point you have to understand. So linear regression is quite sensitive to the outlier. Outliers are the some sensitive information or those data points which are close to our model. But there is no guarantee every data point will be close to our model or every data points will be fit to our line. So that's why some data points which are not close to data points, they are come into the outlier. That is the point we have to understand. So what is the more advantages? That it is just handled to the extrapolation. So all the data points we can say in the mathematically we have a extrapolation, interpolation. So the more advantage or the more important advantage in the linear regression we have the extrapolation beyond a specific data set that we can have to understand. So while doing the practical, while applying the different data set, we feel that is we are doing the work properly. So it is the and second disadvantage with respect to that one we have, it is prone to multi-collinearity. So multi-collinearity we can do, so definitely we can have the good accuracy, but we can't say we are getting the better accuracy. So you can get the good result, but there is no guarantee you can move or you can get the better result. So multi-collinearity we can feel while applying the information in terms of the multilinearity. So while discussing the multiple linear regression, we will feel our model is not suited. But at a time, somehow it is better for some data point, and somehow it is not depend on the data set. So everything is depend on the data set. It will depend on the data set quality or data set information. So model can be fit or suited on our data set information. So everything is depend on the data. What is the data we are using? So based on the data, we have to use the respectively model. So that is the point. The mathematical problem you can solve many ways. But why you are using this problem by the addition? Why you are using this problem by multiplication? So multiplication has own nature and addition has the own nature. So you need to understand if this problem can be solved by the multiplication, then I have to apply the multiplication. Same thing we have over here. So if it is based on the data set, if you try to implement your problem and that is followed by the multilinear regression, then we can solve the multiple linear regression. And when we have to solve any problem with the linear regression, then we can solve such problem with the linear regression. So at the time, the pros and cons will be there undoubtedly. So no model is perfect in this world. So in the machine learning model, we can say no model is also perfect because no model provides the 100% accuracy. But when we have the large volume of data set, so maximum accuracy you can get the 95, 96, 97, 98. But 99.9% you are getting accuracy. It means your model is perfect. But in this world, nothing is perfect. So these are some basic advantages, disadvantages I have discussed over here. Okay. So is it clear to all right now?
Yes, sir.
So these are just only theory portion I have discussed over here. But all the things you will feel advantage, disadvantage while doing the practice. These are the some areas where the linear regression will be applicable. Evaluating the trend and sales estimation. If I need to estimate the selling of a product, so I need to use linear regression or any kind of regression mechanism in simple way. But here you can observe in the linear regression, we have a one independent variable and one dependent variable. When we have the multiple independent variables, then we will talk about the multiple linear regression. So now we have to understand in this case, linear regression can be applicable when we have to identify the selling of the product of the one product only. We are not talking about the multiple products. So that's the point you have to understand. So evaluating the trend and sales estimation, we can do, of course, with this one. Next, analyzing the impact of the price changes. As I told you, the example of the petrol hiking and the food oil, which is hiking in nowadays day to day or month to month. So if we need to change the what is the impact of the price we are getting. So it's 2010, the petrol was very low, but in this case, petrol was triple time costly or expensive in today era when we discuss compared by the 2010 year. Definitely the impact the analyzing we can do with the help of the such model, that is a linear regression model. Risk analysis, yes, of course, while doing anything, and we can measure the our risk analysis based on the some parameter. It is low, medium, high, and very high and extreme. So with this point, I can say the risk analysis can be evaluated with this point. So these are the some area which describe the all the points properly. So what we are getting, how we are getting, all the things are clear to all. Okay, so now it is clear to all right now. The basic introduction part, basic fundamental part is clear to all right now.
Yes, sir.
Yes, sir.
So I'm not going to deeply part of its application area. You can feel the applications part while doing the practical, while feeling the practical, while truly speaking. Okay. So the note for the notes purpose, you can note down all the points in your mind. So just go through the PPTs and read them many times. So everything will be in your mind.